Hello guys! In this video we are going to integrate two specific functions. Probably they are very important because they appear in many exercises, so I want you to have a different form of calculating these integrals. I will tell you that sine squared, cosine squared can be calculated using integration by parts, but let's calculate them in a different form, okay? So our purpose is to use trigonometric identities to simplify this integral and learn how to solve these integrals using this trigonometric property. What do we need? Okay, basic trigonometric identities and understanding some integration techniques. Because we are going to integrate, and at the end we need at least the integrals of the form sine of a function times the derivative or cosine of a function times the derivative, okay? I hope you recall these integrals. Come on, let's start. Okay, we are going to use a property. Which property? The double angle and identity. This means that sine squared equals 1 minus cosine of 2 times x divided by 2. Okay? If you recall this property, then you don't need to use integration by parts. You have a way of calculating this using integration by parts, but if you remember, it takes longer and it takes time, and a lot of mathematical properties. Okay, so let's apply this one. If this is true, I'm going to replace sine squared of x by this expression. As you see, we obtain that thing, the integral of 1 over cosine of 2x divided by 2. I can split this in two integrals, or I can just factor 1/2 outside of the integral and split it again. So I hope you understand that when you are dividing by 2, I can split this in two fractions, 1/2 and minus cosine of 2x divided by 2. Okay, so I split it in two parts. Yes, 1/2 multiplies both parts. Okay, be sure. I hope you have this notion clear. So once you have it apart, then we can integrate. The integral of 1 is x, so piece of cake. The integral of cosine of 2x is a little bit more complicated. Why it's complicated? Because the derivative of 2x is not outside, it's not here, okay, where I have the pointer. What can we do? If the only problem is a constant, I can put the constant and compensate outside. So what I'm going to do, the solution is there, but if I put a 2 here, I need to add 1/2 more outside, okay? Because again, I need a 2 in here, so I got to put 1/2 here. 1/2 is 1 divided by 4. That is the reason this 4 appears. And then the cosine of 2x times 2 is sine of 2x. So the integral is done. You can leave the integral like this. It's already done, but it can be simplified a little bit more. Because you remember for sure, fingers crossed, that sine of 2x is 2 times sine of x cosine of x. Let's see. This is the property, the trigonometric property I'm applying. So I'm not using only one trigonometric property, but 2. Okay? So this is 2 times sine of x cosine of x. The 2 on the numerator and the 4 on the denominator simplifies. So I will have x divided by 2 minus sine of x cosine of x divided by 2. Then I can factor 1/2, and the expression at the end is 1/2 x minus sine of x cosine of x. So it's not difficult. Also, if you can remember the solution of this integral, perfect. If you remember also the trigonometric identity we are using here, even more perfect, okay? But next time that sine squared, the integral of sine squared appears, you can just give me the final solution directly. Okay, or at least know what is the solution and how to reach this point. Okay, let's see another one, the cosine square. The cosine square has almost the same double angle identity. Cosine square of x equals 1 plus cosine of 2x divided by 2. So the only difference between the previous exercise and this one is that here I have a positive sign. In the previous example, I had a negative sign, but the rest is the same. So the integral of cosine squared can be written as 1 plus cosine of 2x divided by 2. I can split that in two fractions, 1/2 of 1 dx plus 1/2 of cosine of 2x. The same process. The derivative of 2x is not there, so I'm going to put 2 here and 1/2 outside. that becomes 1 over 4. So the solution is x divided by 2 plus sine of 2x divided by 4. As in the previous example, sine of 2x is 2 times sine of x cosine of x. Yeah, perfect. So we write it, we simplify the 2 with the 4, and we got x divided by 2 plus sine of x cosine of x divided by 2. I just factor 1/2, and it's exactly the same result as before, but with a positive sign in the middle. Okay, but it's the same exactly. So that is the reason it's not so difficult to remember these integrals. Both have almost the same shape, the solution I mean. And you can use this solution whenever you want, okay? So it's the other option is, okay, I can remember the trigonometric integral, the trigonometric identity, to apply this identity and integrate again. But these integrals appear so many times that if you can save time, in my opinion, save it, okay? So if you can remember this integral, please do it. Okay guys, we have seen how to integrate sine squared, cosine squared in a different way using trigonometric identities, okay? I hope you find this helpful and thank you for your attention.